Thank you everyone for joining us today and welcome to GOWIN's webinar series. Today's presentation will be on our new line of Arora V products. Now for a brief overview of GOWIN Semiconductor. GOWIN was founded in 2014 and its executive headquarters is located in San Jose, California. Our operational headquarters is located in Guangzhou, China. We also have offices worldwide in locations such as Hong Kong, the UK, South Korea, Taiwan, and Japan. With over 250 employees worldwide, we serve the low to mid-range density markets for FPGA needs, from as low as 1,000 LUTs to over 100,000 LUTs. For more information about GOWIN Semiconductor and our latest innovative products, please visit us at gowinsemi.com. At this time, I would like to start our main presentation.
Hello everyone, thank you very much for joining today's GOWIN webinar on GOWIN's new Arora 5 line of products. In this webinar, we're going to be giving you a brief introduction to all of GOWIN's FPGA families of products. We'll have an introduction to the Arora 5 GW5A line of products. The product selection, that's what the family of products includes. The Arora 5 packages available and their compatibility with competitor products. And then we'll talk a little bit about GOWIN's EDA toolchain and the freely licensed IP that GOWIN has available for use in that toolchain. And then Arora 5 development kits. So we'll start then with an introduction to all of GOWIN's products, all of GOWIN's families. GOWIN currently has 3 FPGA product families available. These include the Little B GW1N series of FPGA products on a 55 nanometer TSMC process, the Arora GW2A series of products, which is on a 55 nanometer TSMC process, and the brand new Arora 5 GW5A series of products, which is on a TSMC 22 nanometer technology node. You can see on the right hand side of this slide the market positioning for each series of products. For example, the Little B line of products is competing with the Lattice XO series of products, the Altera Max series of products, and the Spartan 3 series of products from Xilinx. The Little B series is doing very well and has already sold over 50 million units worldwide. So moving up then to the Arora GW2A series, you can see their competitors include the Lattice's ECP series of products, Altera's Cyclone series of products, and Xilinx's Spartan 6 series of products as well. Then finally, Arora 5, you can see on the right hand side, competitors include Lattice's NX series of products, the Altera Aria series of products, and Xilinx's Artix 7 series of products. Introducing the first series of products from GOWIN, the Little B GW1N. It's a flash-based, non-volatile memory product supporting standard interfaces including JTAG, SPI, and I2C, and more. From density points from 1K LUTs all the way up to 9K LUTs. Core devices, the base family include a 1K 5 LUT device, a 2K LUT device, a 4K LUT device, and a 9K LUT device. And we also offer a low power series of products for this family of products, the 1NZ line of products, which includes a 1K LUT device and a 2K LUT device. And the 2K LUT device, the GW1NZ2, is a new device and has new package options available. We also offer an automotive line for the Little B GW1N series of products, the 2K LUT device, 4K LUT device, and a brand new 9K LUT device, all denoted with an A on the end of their product code. As well as the core devices, the low power options, and automotive options, a series of chips including on-chip memory are also available. This uses System in Package (SIP) technology, where you can have a number of ICs on a single substrate, and it allows us to use flash from well-known suppliers. And that includes up to 32 megabits of on-chip SRAM, SDRAM, or pseudo SRAM, as well as on-chip memory. Using the same system-in-package technology, we're offering a system-on-chip variety of these family of products. GOWIN is the only company besides Xilinx to be part of ARM's ARM Design Start Scheme to offer M1 to M3 lower-end ARM devices included with our FPGAs. There are soft-core and hardcore options available for this. It includes the GW1S4 and GW1S4C with the ARM Cortex M3. And then you can have a combination of both SoC and on-chip memory in the form of the GW1N-SR and the GW1N-SR4C family of products. GOWIN has also partnered with Intrinsic ID to offer a security solution on this family of products as well. And at the bottom of this slide, you can see the GW1N family pin-compatible competitor devices. These include Lattice's XO series of products, as well as Intel Altera's Max series of products. GOWIN's Arora series of FPGAs, the GW2A series, includes a 10K LUT device, a 20K LUT device, and a 55K LUT device. The base family includes the GW2A18, which is advertised as an 18K LUT series of devices, but actually the devices are closer to 20K LUTs, and the GW2A 55K LUT range of devices. Similarly, this range includes an automotive series of devices, the GW2A 18A, as well as system-in-package offerings for on-chip memory and on-chip flash, where flash is denoted by an N at the end of the product name for GW2AN, and RAM is denoted by an R for GW2AR. And then you can have a combination in our GW2ANR 18K series of devices for flash and RAM. And at the bottom again, we can see the pin-compatible competitor devices for the Arora GW2A family of products, which include Lattice's XO series and ECP series, Intel Altera's Cyclone 4 series, and Xilinx's Spartan 6 series of products. And that brings us up to speed to talk about GOWIN's latest offering, the Arora V line of products, the GW5A series. The Arora V is a low-power, high-performance, mid-density range of FPGAs. It's developed on a TSMC 22nm process, which is ultra-low power and offers the best cost break for silicon area. It has multiple offerings, including high-speed SerDes from 270 megabits per second up to 12.5 gigabits per second, PCIe up to 8 channels, MIPI D-phy, MIPI C-phy, DDR3, LVDS, PLL, as well as on-chip ADC and an embedded high-performance RISC core. It also offers exceptional SEU, that's single event upset protection, but more on that on a later slide. Let's take a look at the Arora V GW5A family of products family overview. It includes, at the moment, density points of 25K LUTs and 138K LUTs. These devices are in production right now. We're also offering 60K LUT and 75K LUT devices sampling Q4 of 2023, and a 15K and 45K LUT series of devices sampling in mid-2024. There's a base family of products from 25K LUTs up to 138K LUTs, as well as a transceiver model of products denoted by a T from 15K LUTs all the way up to 138K LUTs also, as well as a micro SoC line of products, that's hardcore SoCs using the same system in package technology as we've seen before, available for the GW5AST138K line of products, which includes a hardcore RISC-V AE350, as well as coming very, very soon, the GW5AS25 series of devices, which include a hardcore ARM Cortex-M4, and that's coming very soon. And at the bottom, we can see, again, the list of GW5A family pin-compatible competitor devices. From Lattice, we have the Crosslink NX and ECP5 series of devices. For Intel Altera, we have the Cyclone 4 and the Cyclone 5 series of devices. And from Xilinx, we have the Spartan 6 and Artix 7 series of devices. Taking a look at the family tables for the Arora 5 device, that every title that's underlined includes a link to GOWIN's website where you can find out more. As mentioned previously, devices highlighted in green, i.e. the GW5A series of products and the GW5A138 series of products, are available right now, and devices highlighted in blue are coming very soon. It's worth mentioning on this slide that I didn't mention in the previous slides that the GW5AR25K LUT device is due to be sampling in Q1 of 2024. So looking at some of the key features then, the number of flip-flops or LUTs per device range from 15,000 LUTs all the way up to 138,000 LUTs. The RAM offerings for these family of devices are on par with our competitors, with distributed RAM up to 1080 kilobits and on-chip block RAM up to 6000 kilobits. This family of devices also offers advanced PLLs, which support spread spectrum clocking. A brand new advanced DSP architecture is available for these products. And it's interesting to note that Arora 5's MIPI functionality uses standard GPIOs and do not require MIPI-specific pins. It should be noted, though, that all GPIOs configured as MIPI will require stand termination resistors. Arora 5 includes DDR3, MIPI D-phy, and has core voltage options. For most products, this includes two core voltages from 0.9 to 1 volt, and for the GW5A25K series of devices includes an additional 1.2 volt option. Transceiver-supported devices, denoted with a T for transceiver, or ST for SoC with transceivers, offers up to 8 channels of PCIe with larger density devices, which is package specific, and high-speed SerDes. So I'm going to take some time at this point to talk about the part numbering for the Arora 5 series of products. You would have seen on other slides, we've hinted at part numbering, so I'm just going to go through a little bit now of what that exactly means. To start off, you have GW5AX. This is the product series, GW5A for Arora 5. And this may be adorned with an extra letter or two, with R for memory, T for transceivers, S for micro SoC, and ST for micro SoC including transceivers. Then you'll see a dash with the core supply voltage denoted, LV for 0.9 to 1.0 volts, or EV for the GW5A25K and GW5AT60K devices for 1.2 volts. Then we'll have the logic density. This is fairly simple, from 15 up to 138 denotes the thousands of LUTs. And then package type. And finally, on the end, we'll have a speed grade. This is denoted by either a CX, IX, or AX, where C stands for commercial, I stands for industrial, and A stands for automotive. Followed by a number from 0 to 2, where 0 is the slowest speed and 2 is the fastest speed. On this slide, you can see the package options available for the GW5A Arora 5 family of products. It's worth mentioning at this point that this is not the final list of package options available, and other offerings will be coming very, very soon. Similarly, on the previous slide here, you'll see everything available now highlighted in green, and everything available very, very soon highlighted in blue. On the right, you'll see pin-compatible devices. This as well is not a full and extensive list, and if required compatibility is not seen, do reach out and speak to us to see if we can find a device to fit your requirements. There are two package types available, including wire bond package chips and flip chips. The difference between them is, as opposed to wire bond, flip chips solder pads are connected on top and then flipped over. This means that the chip sits directly on the circuit board and has shorter contacts, which means that there are faster speeds available for serial data transfer. In flip chip packages, high-speed SerDes is spec'd at 12.5 gigabits per second, but we've seen 13 gigabits per second in the field. Wire bond is far more affordable and still offers excellent SerDes performance, spec'd at 8 gigabits per second, but we've seen up to 10 gigabits per second seen in the field. If SerDes is the biggest requirement for the device part, then flip chip is recommended. Let's go over some of the highlights of the GW5A Arora 5 series of products. High-speed transceivers are included, up to 8 SerDes channels at 12.5 gigabits per second per lane. This is package specific, as I've mentioned before. PCIe, up to 8 channels. Root port and endpoint dual modes, this is also package specific. Arora 5 currently supports PCIe 2, but will be supporting PCIe 3 very soon on the same product line. Flexible high-performance MIPI D-phy hardcore TX and RX at 3 gigabits per second. Flexible PHY can support 2-lane inputs and 2-lane outputs, and this is available on any standard GPIO. More on the advanced GPIO. Each GPIO can support EasyCDR, that's a clock data recovery system which enables clock recovery on differential data streams with an embedded clock. Using standard GPIO with speeds up to 2.5 gigabits per second without using SerDes hardware. Can also cascade, supporting multiple LVDS channels, so long as the LVDS channels are in the same group, clock sharing to recover resource over multiple channels. EasyCDR can be implemented without using SerDes hardware, which allows any standard GPIO to implement lower speed SerDes applications, including USB 2.0, HSIC, HDMI, and more. On top of everything else, Arora 5 offers exceptional radiation resilience. Diving a little bit deeper into the Arora 5's radiation or single event upset resistance, Arora 5 further distinguishes itself by delivering exceptional SEU resiliency compared to its competitors. GOWIN's innovative approach adopts custom-designed SRAM cells to significantly reduce soft error rate effects. To make the handling of SEU-related matters more accessible, GOWIN provides an SEU Handler wrapper IP, which allows users to seamlessly access SEU reports and correction functions, enhancing both reliability and efficiency. The Arora 5 series of products can detect 3-bit errors while correcting 2-bit errors, and the 138K family can correct single-bit errors. Let's take a more in-depth look at some of Arora 5's features, starting with GPIO. All GPIOs include 3.3 volt legacy mode support, and all differential IOs support MIPI C-phy and D-phy, as well as EasyCDR, a clock data recovery protocol which I discussed on a previous slide. Arora 5 supports multiple configuration features. A wide range of configurations that you can see listed at the bottom of the slide. Some of the more important features to pick out are AES encryption and decryption. The support of OTP 64-bit one-time programmable identifiers for each device, enhanced bitstream compression, and advanced SEU single event update protection as seen in previous slides. All Arora 5 devices across all density points support MIPI on any standard GPIO, with MIPI D-phy, RX and TX up to 3 gigabits per second with the D-skew function. MIPI C-phy is also supported across some devices. On the bottom left of this slide, you can see the hardcore MIPI performance across some of our devices, as well as on the right, you can see photos taken from a loopback BER test, which passed at 3 gigabits per second with a 25K LUT device. Continuing on the conversation of Arora 5's MIPI performance, here are some stats and figures on Arora 5's current device offerings, as well as some information on the MIPI performance of upcoming models. Arora 5's embedded ADC and sensor IP includes a Sigma Delta ADC with 10-bit resolution delivering high accuracy that supports internal voltage and temperature measurements, with a temperature accuracy of plus or minus 4 degrees C without trimming over a negative 40 to 100 degrees Celsius range, or 105 degrees Celsius for automotive parts, and a voltage mode accuracy of plus or minus 1%, delivering high accuracy internally or using external input using GPIO pins. Let's talk a little bit about Arora 5's SerDes solution for the GW5AT series of devices. GOWIN's SerDes architecture is more flexible than its competitors, allowing customers to implement their own IP for protocol features and providing multiple input and output points through the chain. As you can see in the diagram, soft IP functionality is observed in white and hard IP functionality can be seen in blue. Arora 5's SerDes solution offers speeds from 270 megabits per second up to 12.5 gigabits per second. This is package dependent, as we've spoken about in previous slides. The solution includes dedicated RX and TX channels and an integrated 8-bit 10-bit encoder-decoder. The three main components include the PCS, the physical coding sublayer, which deals with TX coding, RX decoding, scrambling and unscrambling, supports multiple protocols, Ethernet, CPRI, SDI, and more. The PMA, the physical media attachment, deals with gearboxing, clock recovery, and typically contains two SerDes, RX and TX. The PMD, the physical medium dependent, deals with the serial signal transmission driving the I/O. SerDes has multiple uses, including gigabit Ethernet, XAUI or 10 gigabit attachment unit interface for a chip-to-chip interface, PCIe, and more. This slide contains a quad overview of GOWIN's Arora 5 SerDes solution, supporting up to 12.5 gigabits per second data rate with continuous frequency range, easy to use pre-emphasis and auto-equalization to enhance signal integrity, configurable PMA, that's the physical media attachment, and PCS, the physical coding sublayer, including multi-quad, quad-base, and channel-base. It's a fully in-house design that's easily upgradable for new customer opportunities. The Arora 5 GW5AS and GW5AST include an embedded RISC-V AE350 SoC. This includes the core system, memory system, and bus peripheral system. The RISC-V bus peripheral system includes an AHB bus and an APB bus peripherals. We can extend to more peripherals on these buses in the FPGA fabric. These peripherals can include I2C, SPI, UART, GPIO, etc. And they're in the AE350 RISC-V hardcore and don't use FPGA logic resources. There is a GW5AT development kit available, including the embedded AE350 RISC-V core, the DK Start GW5AT LV138, which is available now. Like all of GOWIN's products, the Arora V line of FPGAs can be programmed using the GOWIN EDA tool. The tool is free and can be downloaded from the GOWIN website. Once you've applied for a license, which is also free, you're good to go. The EDA tool is a free licensing model, as I've just mentioned, supports standard text entry support, VHDL, Verilog, and System Verilog, has fixable floating licenses, and it's very well liked by the customers. GOWIN's EDA tool is available for the Windows and Linux operating systems. It's a fully featured toolchain, including a free IP core generator, floor planner, systematic viewer, which is very useful for debugging, and a standalone programmer. GOWIN's EDA tool also supports simulation using third-party tools such as Model Sim, and GOWIN also has its very own simulation partner in the form of Metrics, offering cloud simulation using DSim Cloud. As I mentioned on the previous slide, GOWIN's EDA tool includes an IP core generator, offering freely licensed soft IP in a number of different categories, as shown on this slide. This includes many interfaces, encoders, anything you might need to get your project up and running. Some of the larger IP cores are available on our website, but not everything is. All IP we have available is included in the EDA tool's IP core viewer. If your design requires IP that you don't see in our core generator, and you think it would be good to have in there, do let us know. It might be something that we've worked on before in-house and we haven't put on the EDA tool or on our website, or it could be something that we can work with you to provide. Some of our larger freely licensed IP cores include soft-core microcontrollers, including the ARM Cortex-M1, ARM Cortex-M3, and an Andes RISC-V processor. SoCs can be configured in GOWIN's EDA tool SoC Builder, where peripherals can be configured in the tool. 2 development kits are available for the Arora V series of products, the GW5AT138 board and the DK-Start GW5A25 board. The GW5AT138 board includes 4 gigabits of DDR3 SDRAM, supports multiple interfaces including MIPI, PCIe, HDMI, and has a USB JTAG bridge in the form of an onboard GW-U2X module. It's also compatible with many GOWIN GW5AT138 daughter cards for specific applications. The DK-Start GW5A25 board includes 2 gigabits of DDR3 SDRAM, has 4-channel LVDS, 4-channel MIPI, 3 ADCs, a HDMI interface, and 18 fully programmable GPIOs. Well, that's it from me today. Thank you very much for your time and listening to my presentation about GOWIN's new Arora V series of products. I'll now hand it back for general questions and Q&A.
All right, thank you, Jack, for that presentation. We're moving to the Q&A portion of the webinar. Please send us your questions, and we will answer them now. If we happen to run out of time, we will answer those questions through email. Okay, so question number 1 I have here is the DDR3 interface a hardcore or softcore? And if softcore, how many LUTs does it need?
That's great. Thanks, Andrew. Hi, guys. Thanks for joining today. I'm Danny Fisher. I'm the Senior FAE Manager at GOWIN EMEA. So I'll be taking the questions from today's webinar. So the DDR3 in the GW5A series devices is actually implemented within the FPGA fabric. So the memory controller interface is essentially a soft core. In terms of the resource utilization, it really depends on the application. So the amount of lookup table resource that's used is really determined by the DQ data width, so how many bits you're using for the memory. So for example, an 8-bit memory bus uses about a 1K LUTs for the controller and 72 bit data width would use about 2,500 LUTs. So it is very much application dependent, but it's pretty frugal in terms of the actual resource needed for that interface. And it will run, as you've seen in the webinar, up to 1.33 gigabits per second, which is pretty good. Okay, thanks, Andrew. Do you have any more?
Of course. Yeah, thanks, Danny. Let me check here. All right. Next up we have, does the GOWIN FPGA company support Sony's high-speed interface standard? So SLVS EC.
Yeah, okay. Okay, so one of the most challenging aspects of delivering a new FPGA family is really being able to deliver an EDA package, which obviously includes the IP cores that are essential to delivering a usable platform. So customers need to have access to various IP cores to build their applications. That's where we really focus a lot of time and effort. So the silicon is obviously one part of the challenge, but the IP, the infrastructure, EDA tools is probably the bigger challenge, to be honest. And we're adding new IP cores all the time. The Sony IP cores, so the camera interface, the SLVS EC as a receiver IP core controller, came available about 2.5 months ago. So that was that IP core has been around for a little while now as a reference design. So we have that capability. As you've seen on our list of IPs, we have quite a few IP cores dedicated to the Arora 5, particularly those that use the SerDes interface as well. And that list is continually growing and expanding. So as we see new customer opportunities, as customers request new cores and we add new functionality, that list of IP cores will continue to grow. And as always, GOWIN's IP licensing model is completely free. So we offer our cores at no cost. Okay, thank you.
All right, thank you. Next up, in addition to measuring internal voltages and temperature, can the embedded ADC also measure external analog inputs?
Okay. So there are different options for the internal ADC on the GW5A series, depending on device. All the embedded ADCs are able to measure on-chip voltages, so they're actually able to look at things like the core supply and that kind of thing. And they're also able to measure temperature. So they can give a pretty accurate temperature measurement as well, which is obviously very useful and can be used for PVT type control applications. Maybe you're interested in the core voltage, or you're going to throttle the performance based on temperature. However, they can also be used as more traditional ADCs. So they do have a dedicated input pin. And you can use that to measure external analog voltage levels. And you can actually route signals through our advanced GPIO structures, which include a bypass mode, so you can bypass the input buffers as well, and route voltages to the ADC via the standard GPIO as well. So it's a very flexible architecture. You can measure multiple channels and that kind of thing. So ideal for checking voltage levels on your hardware, for checking device internal voltage levels, measuring temperature, or external signals as well.
All right, awesome. Thanks, Danny. Next up, what are the differences between using standard GPIO for MIPI and the embedded MIPI hardcore?
Okay, so the short answer, or in summary, I would say that the MIPI hardcore generally offers higher performance than when using GPIO for MIPI. So when you use GPIO for MIPI, you need to add the external termination resistors for the MIPI interface. You use the IP core generator, for example, to generate the MIPI D-phy as a soft core. Obviously, in the hard core, you have the terminations embedded in the device, so that saves some BOM items and makes the PCB design all that much easier. And obviously, the hard core, as you would expect, can achieve higher performance than a soft core D-phy type implementation using the GPIO. So I'd say typically a hardcore MIPI is about 500 megabits per second to 1 gigabits per second per lane faster than using GPIO for the MIPI implementation. So what I would say though is that the GPIOs are very useful. So for lower speed MIPI applications, they allow a wider range of pins to be used for the MIPI interface. So if you're not pushing the limits of the MIPI, and not everybody does, then being able to use general purpose GPIO for the MIPI is very handy. So it essentially increases how many MIPI interfaces you can have, and also their locations, which can also be important. In terms of the MIPI support, so we have different options with the different devices within the Arora 5 range. So for example, GW5A138 and 5AT138 and the GW5AT75 both support 2 hardcore MIPIs. These are RX only modules supporting up to 4 lanes of data. The GW5AT60 supports 1 MIPI hardcore, but it's D-phy or C-phy, and it supports RX or TX, so you can use it for either. The GW5A45 actually has 2 MIPI hardcores, D-phy or C-phy, RX or TX, and then the GW5A25 has 1 MIPI D-phy hardcore, again RX or TX. So there are different options open for the hardcore. All the devices support MIPI using GPIO as well, and we have tables, data rates, and things like that for the various devices if needed. Thanks,
Excellent.
Andrew.
Of course. Next up, what are the advantages of using EasyCDR over normal SerDes?
Okay, so EasyCDR stands for Easy Clock Data Recovery. This is using applications where the clock is embedded in the data. So the clock needed to recover the data is embedded in the LVDS data stream. So we're using coding generally to make sure that the LVDS stream has a high enough toggle rate, so at the receiver we can recover that clock, and then we can use that clock to align to or to sample the received data. Now, the advantage of EasyCDR is that it can be supported by any of our differential I/O. So where you have applications where you want to pass data at relatively high rates, and we support rates up to about 2.5 gigabits per second, rather than using a dedicated SerDes hardcore block, obviously the number of SerDes instances is limited in the device. You can use any differential I/O to build relatively simply a data transfer system using the EasyCDR IP. So EasyCDR has advantages for lower speed SerDes-like applications, and means that you don't have to use a dedicated SerDes hardcore, which means EasyCDR actually will work even with our non-transceiver based devices as well. I think that pretty much covers it. Thank you.
Awesome. And I do see one more question here. You mentioned PCIe 2.0 support is available now, but as 3.0 support becomes available, will I need new parts?
Okay, so our GW5AT transceiver-based devices include essentially hardcore PCIe support. Initially at PCI version 2.0. We are working on PCI version 3.0. Obviously, that provides higher data rates. That will essentially be a change to the IP. So it will be completely compatible with the devices that we have currently. So if you have a GW5AT 138 and you have PCI 2.0 now, but you essentially PCI 3, when it comes available, will also work on that platform. So you will not need different devices. It will be pretty much seamless.
All right. Looks like that's all for our questions. Thank you everyone for participating in today's webinar. A recorded video of this presentation will be available by tomorrow, and you'll be sent a link directly to the same email you used to register for this webinar. This concludes the webinar. Thank you, stay safe, and have a great one.